Hey everyone, welcome back to the Foundations of Pre-Calculus 10 videos. In this video, we're looking at Lesson 3 from Chapter 3, which is talking about common factors of a polynomial. Now before we move on to our new information, we first need to do a quick review of the distributive property and multiplying and dividing polynomials, which you all would have learned in grade 9. So here we're going to look at the distributive property first, which I also like to call shooting my arrows. So here we'll look at expanding the following. Here we have 3 times a binomial 4x plus 1. So I like to call this shooting your arrows because you take your first number and you draw arrows pointing to each of the terms inside your brackets. So it literally looks like you're shooting arrows to each of those numbers. And every time you shoot those arrows, that means multiplication. So here we're going to go 3 times 4x. And then we're going to separate this with a plus sign. And then 3 times 1. So this 3 multiplies to each of those terms. And you'll know it's each term because they're separated by a plus or minus sign. Then you can go ahead and simplify this. So when you multiply 3 times 4x, you multiply the two numbers together to get 12. And then you tack on the x beside it. And then you can do your second one, which is 3 times 1, which is just 3. So that is a quick recap of using the distributive property, or what I like to call shooting your arrows. Now our second review will be on multiplying and dividing polynomials. So when we multiply two of the same variables, what we do is we add the exponents. And if we don't see anything there, then we just assume that it's 1. When we divide 2 of the same variables, what happens here is that we subtract the exponents instead. So multiplying means we add, dividing means we subtract. So here we have the example 2r times 6r. So when we're multiplying a variable and a number, what happens is we multiply the two numbers together and multiply your variables together. So we start with multiplying 2 times 6, which is 12, and then r times r. Here we add your exponents. When we don't see anything there, we can assume that that is just a 1. So we have a 1 plus 1 as our exponent. And we can just simplify that to r squared. So here we're going to look at division. So once again, we're going to look at the numbers separately and then the variables separately. So here we have 40 divided by negative 10, which would give you negative 4. And here you have k divided by k. So here would be 1 minus 1, and we're subtracting because we are dividing. But when you look at that, you have k to the power of 0, and anything to the power of 0 is just 1. So this is actually negative 4 times 1, which is just negative 4. So now we're going to move on to some new material, and we're going to look at factoring a polynomial. So in order to factor a polynomial, what we need to do is we need to write it as a product of polynomials. And so essentially it's the opposite of the distributive property. So what we're going to be doing, I'm just going to flip back to this example, is we're going to be looking at something like this 12x plus 3, and we want to rewrite it looking like 3 times 4x plus 1. So it's literally the opposite of your distributive property. So we're going to be starting with a polynomial like 12x plus 3 and writing it like 3 times 4x plus 1. So essentially what we want to do here is, here we multiply by the same number. So now what we want to do is remove a number that's in common with both of our terms. So we're going to be looking at example number 2 from your notes. That's in your factoring section. So here we're going to factor the trinomial 6 minus 12z plus 18z squared. And then we're going to verify that the factors are correct. So one thing to note is that when we're trying to factor any type of polynomial, we always want to make sure we remove the number or the biggest number that's in common with each term within that polynomial. So essentially what we're looking for is our greatest common factor, or the GCF. So what we want to do is we want to make it into its simplest terms. So it's kind of like when you're trying to reduce a fraction. Like say we had 12 over 24. You wouldn't want to just divide each number by 2, because then you'd only be left with 6 over 12. That's still not in its simplest terms, so you'd have to divide it again by 6 to get 1 over 2. So essentially what we want to do is look for that greatest common factor and reduce it to its simplest terms. So same idea over here. We'll look at each of our numbers and see if there's what number or what our greatest common factor is between all three of those numbers. So here we're just going to first examine our numbers. We have 6, negative 12, and positive 18. So you want to ask yourself, what is the biggest number that can divide into all three of these numbers? And so here in this case, your GCF would be 6. So what you're going to do is you're going to write 6 on the outside, and then you can write a bracket in the middle. And then what you want to do is you want to divide each of those terms by 6 to get our resultant polynomial, or what's inside our brackets. So we go 6 divided by 6 is 1. We have negative 12z divided by 6 is negative 2z. We have 18z squared divided by 6 is 3z squared. So we'll separate that with a plus sign. So we get plus 3z squared. You might also want to check if there is a common variable that you can take out. Like say if there was another z connected with a 6, you might be able to pull out a common factor of z as well. But just in this case here, we only have the number that's in common, and so now we have factored this trinomial. You might also want to check to make sure you have everything in simplest terms. And so 1, 2, and 3 are prime numbers, which means that we cannot reduce or simplify our polynomial anymore. So things are looking pretty good. The last little thing that we need to do here is that here we need to verify that our factors are in fact correct. So we're just going to make sure that our work was right. So in order to make sure our work was right, we're just basically going to go backwards. We're actually going to distribute that 6 into our polynomial and show that we get the same answer here. So I'm just going to start by rewriting our answers. We had 6 times 1 minus 2z plus 3z squared. And then I'm going to distribute or shoot my arrows. Remember, my 6 is going to go to every single term. And remember, your terms are separated by plus and minus signs. So our first arrow went to 6 times 1, which is just 6. We have 6 times negative 2z, which is negative 12z. Then we have 6 times 3z squared, which is positive 18z squared. And so what we should see is that this matches exactly what we had in our original question. So that is how we know we did our work right. And then we can feel pretty confident about our answers then. So that is everything for this video. So if you guys have any questions, make sure to come see me in class, or feel free to text me on Remind 101. And thank you guys so much for watching.